Welcome back, everybody. This is going to be our Algebra 2 Function Foundations, lesson number 4, Domain and Range of a Function, Homework Review, Part 2. And so hopefully you guys watched Part 1 and found it helpful. There was a number of things we went over, and we're going to continue with determining how we find the domain of a function. And if you guys watched the first one, we saw a situation where we had what we call a rational function, some type of expression where there was a fraction and an algebra expression in our denominator with a x value, and had to determine what the domain is based upon that. And so that's one thing to look out for. So today we're gonna for this video we're gonna look at some other things too. But first, you can, if you really sorry. If you can, we'd appreciate if you could please give this video a like if you find it helpful. Leave any comments and questions below. We'd love to hear feedback from you guys and know what things are working out correctly and what things would really help to make things learning better for you. So here we go. Number 5. Which of the following values of x does lie in domain of the function defined by g of x equals the square root of 2x minus x? Okay, so we have a square root function, and so we have a second thing to look out for. So remember, the first thing we said when determining the domain of a function, we should normally look out for one of 3 possible situations. 1, when the value of x makes the denominator fraction equals 0. We did that. Okay. 2 will be when the value of x makes the radicand of a square or even root radical negative. Now, the radicand is the number underneath the radical. Okay, so the little house symbol is the radical, and the expression or number underneath the radical is the radicand. So it's a square root or even root radical, meaning if the index is an even number, whether it's square root, the 4th root, the 6th root, the 8th root, and you're going, wow, you're going to have roots that are like, go that far? Yes, Algebra 2, we're advancing. So just understand that for domain, we cannot have any radicand to be negative in a even root radical. Okay, because if we're dealing with real numbers in this case. When we go past real numbers, we can make some changes then, though. Okay, so whenever the number under radical equals square root is less than 0, then the expression is no longer a real number. So, like, what do we mean real, and what else could be? Well, we're going to explore something called, what's not real is imaginary numbers, which we'll get to in time. For now, let's just say in this case, if you were to try to take the square root of a negative number, your calculator would go error. Okay, and so non-real number, and so we will talk about that and find a way to get around that in calculator when we start expanding our set of numbers. So we set the radicand to be greater than 0, and so an example would be in this case, g of x equals the square root of x plus 2, and so to be able to solve for this, what we would do is we would set x plus 2 to be greater than equal to 0. And so we would just subtract 2 on both sides and get x to be greater than negative 2. And that's what our domain would be, okay? And so that's how we approach this type of problem, which leads us back to our question here. Which of the following function values of x lie in domain defined by in this case, the g of x equals 2x minus 7. All right. So here, what we're going to do is we're going to set the 2x minus 7 to be greater than or equal to 0. All right, and so add 7 both sides. We get 2x is greater than 7. X divided by 2, x has to be greater than 7 over 2, or x is greater than or equal to 3.5. And I think I might have jumped the question we were looking at before, but we'll take a look though. So x has to be greater than 3.5. Well, which number is greater than 3.5? Well, heck, it's got to be x equals 5. So here we see 3 cannot work out. 2 or 0 would make our radical negative. Okay, so this is how we find the domain. Now, our domain really would be, so our domain would be x is all values of x greater than or equal to 3.5. All right, and I didn't jump the gun. I thought I did. So it's just tough because sometimes keep track of the part one, part twos. Just want to make sure I get all the questions down. So, all right. So our domain would be x has to be greater than 3.5, and the only choice given to us here that works out is going to be choice 4, x equals 5. Does that make sense? Now, x equals 4 works out to x equals 3.6, 3.5, 3.51, 3.52, but 3.4 is no good. 3.49 is no good. 3.4999999 is no good because it creates a negative number in our radicand. So number 6 is very similar to this. Which the following represent the domain of the function y equals the square root of 6 minus 2x. Okay, so what we did before, we're going to take the radicand to 6 minus 2x, and we're going to set that to be greater than or equal to 0. All right, so we're going to subtract 6 on both sides. Now we have negative 2x is greater than or equal to negative 6. Divide both sides by negative 2. Now here's the tricky part. When dealing with inequalities, whenever you multiply or divide by a negative number, we must change the direction of the inequality. So we get x on the left side, positive 3 on the right side, but it now goes from greater than to less than. And so our domain should be x is going to be less than or equal to 3. And that's going to be choice 3. We see this as also called set builder notation. And so the interpretation is going to be for all values of x such that x is less than or equal to 3. Okay? So that's how we find domain. Right? So we see in this case, it's not a big deal. All right? With a radical, we set that to be greater than or equal to 0. If it's in the denominator, we set that the expression to not equal to 0, and that we know what all values x cannot be, and x can be everything else. So let's move on to our next question. Well, before we go to the next question, actually, there is the third example. I said 3, all right? So what could the third one be? The third one would be the following. When there is a square root or even root in the denominator, the values of x cannot make the radicand negative, and it cannot make the radicand equal to 0. So we set the radicand to be greater than 0. So here, for a third situation, h of x is equal to 1 over the square root of x minus 7. Instead of setting x minus 7 to be greater than or equal to 0, it's just greater than 0. Okay? Why? Well, first off, greater than 0 is positive, and not equal to 0 because you cannot have a 0 denominator. So we just add 7 to both sides. So therefore, our domain would be x is greater than 7. And so we see here in this case, it's kind of a combination of both 1 and 2 together. Do we have these? You betcha. And will they get more complicated? Of course they will. All right, but keep these three things in mind. So here is our set of rules to trying to calculate domain in this situation. All right. Okay, pause the video if you need to write everything down. Totally good. All right. Let's move on to our next problem. It's full screen again. So here, the function y equals f of x is completely defined on the graph shown below. And I apologize, I don't have a stylus. I got to figure out how to find one that will work for my computer. So it kind of looks a little ugly. But I did plot the points though, so we can look at those values. So we want to evaluate f of negative 4, f of 3, and f of 6. Okay, so f of negative 4. So f of negative 4 would mean we would need to find out what is the y value. What is the y value when x is negative 4? So 1, 2, 3, 4. X is negative 4. The y value is 1, 2, 3, positive 4. So we have in this case equal to positive 4. Now let's find f of 3. So let's find f of 3. So here we go. Go 1, 2, 3 to the right. And then we find the matching y value. 1, 2, 3, 4, 5 right here. And so that would be f of 3 is equal to 5. And finally, f of 6. All right. And so f of 6, let's take a look. X is 1, 2, 3, 4, 5, 6. And we see the matching Y values down here. 1, 2, 3, 4. That's going to be negative 4. All right. Okay. So that's how we evaluate these things. We actually did a little bit of this the previous lesson when talking about function notation. And so hopefully this is okay. Now, let's take a look. Draw a rectangle whose vertices are negative 4, comma 5. So let me just plot those points there. All right, so I'm going to use a blue. So negative 4, 1, 2, 3, 4, and then positive 5. 1, 2, 3, 4, 5. So this is going to be our first coordinate. 6, comma 5. 1, 2, 3, 4, 5, 6. 6, comma 5 is up here. 6, comma negative 4 is going to be down here. And negative 4, comma 4, so negative 4, comma negative 4 is down here. And so we're going to create a rectangle. A rectangle is here, and let's see if we get a rectangle. Maybe, yeah. Okay, here we go. And then let's create this rectangle. All right, come down this way. All right, so we're creating a frame here. All right, so that's okay. I can adjust this a little bit. Okay. All right, so now it says here, now we have a rectangle drawn. State the domain and range of this function using interval notation. Okay, so we know our domain, it stops off the x value, the leftmost x value is negative 4. Okay, so it's going to be negative 4 here. Okay, so negative 4. And we're including, now in this case, the rightmost x value is going to be 6. All right, so we're including these values here. So this would be another way to write domain, but they wanted us to write this as interval notation. Interval notation is unlike set build notation. So set build notation will look something like this. So we'd have a x here with a little bar, x dot dot here, and this would be set build notation. All right. Actually, the other way around, I think. I think it should be this way. I think it should be x such that x bar. No, I think it's the other way around. So, in any case, I think it was perfectly fine before. All right, so x such that. Okay, but interval notation means in this case that we're going to use the focus on the numbers here, the leftmost number and the rightmost number, negative 4 and 6. So we definitely have negative 4 and 6, and we're going to use in this case these hard brackets. The hard brackets mean we're including those endpoints. Okay, so our domain would be starting at negative 4, going all the way to 6 without any breaks. The range for us, our lowest value is going to be negative 4. We're including that value, and the highest value is going to be 5. This is our range. And so for interval notation, we'd have negative 4, comma 5 with the hard brackets, or this kind of the instead of parenthesis would mean we kind of like don't include the endpoints. But with these little squared off brackets here, that means we include the endpoints. And so this would be the domain and range in interval notation. Okay? All right. And then I believe there is one. Oh, that's it. All right, ladies and gentlemen, this is the end of part 2. Hopefully you found it helpful. Please leave the video a like and leave any questions or comments in the comment section below, as well as feedback. Hopefully the words we use of interval notation, we can talk about a little more in the next video. We might see a little more, and you know, please, if you have questions, I can do a video for a particular topic that we talked about a touch, but may not got into. So this way you have knowledge of this. Okay, ladies and gentlemen, thanks so much for watching. I'll see you in the next video.